feedback control system. Feedback control system, all in one. Then you have input, and you have the overall transfer function GS, and this is the output. And here I said that the overall transfer function will be output over input. That's what we did. And then I gave the example that for this, the overall, sorry, this is TS, overall TS. Overall, we just write a TS and we write a transfer function like that. This is the overall transfer function. Output over input. This is what I wrote last time when we were doing mass spring system. So you can actually find, so you have a input, reference input, then you have a system, then you have the output. You can take an individual component, look at its input and output, the transfer function for that particular component will be output. And you move to the next one. And the next one is the system itself. Then you get input and output, you divide it and get its transfer. And you combine it. Combine all. And that's what I'm going to do in a minute. I will combine everything. I will combine everything. I'm doing it very slowly so you understand it. Once you understand, then it will be very easy for you to solve questions. Although it's just a, really it's just a statement, because when you will start solving it, there will be a lot of headaches. Because you can't solve these things very easy. We will do something today, and you will understand the complications which might appear when you have complicated systems. So, now, what will happen? This is something which is important, that if you have, instead of one system, you have two systems, then what you will do? So, you have your input R1, right? Let's say it's R, and then you have a system, let's call it G1, this transfer function, and then it gives you R2, which another system, this transfer function is G2, and this is your control output. Now, what should I do to combine this whole system into a single transfer function, where you have R in, C out? So please do that. Think about it. What to do? Think about it. Now you have two systems. What to do? Yeah, here. Yes. I was worried because it was written question too, and there was no thing. So it should be very simple because you have to look at the transfer functions of each one. So what is the transfer function? This one is G1. So G1 equals, let's say it's R1 rather than R1. So it's okay. R1 over R. That is our definition, right? Output over input. From here, R1 will be equal to RG1. Yeah, simple. Cross multiplication. For the second one, G2 will be equal to C over R1. So from here, right, C over R1, and then you can simplify it. So simplify it. Simplify it. Simplify it, please. So you will have C equal R1 G2, and R1 is RG1. So you have R G1 G2. So it simply means that your function will be now G1 G2, because from here G1 G2 will be equal to C over R, which is our overall transfer function. So it's like resistance in series, right, or resistance in parallel. Here you have two systems, right, and then by applying the transfer function rule for individual components, you end up with a very beautiful thing. That if you have two systems and their transfer functions are given and they are in series, remember, this is only applicable if they are in series. If they are in series, then the overall transfer function will be equal to the product of the transfer functions of two systems. And that's what we proved by looking and applying the definition of each one individually, finding the value of R1, putting it back there, and you get your answer. And this is your first thing which we have to do. Another